Hello everybody, it's Marco Venere, a PhD student in Information Technology in MATLAB at Politecnico di Milano. And today I want you to present some outcomes of a collaboration between MATLAB and MathWorks, where we support and enhance the learning of quantum algorithms for our students, bridging theory and practice. Well, the context is quantum computing, which is a novel paradigm of computation which is based on qubits instead of bits. While a classical bit can only contain one out of two different states, a qubit can instead contain a superposition of two states, and this gives room for exponential speedup compared to classical literature for a huge number of use cases, starting from factorizing integer by Peter Shor in 1994. We have had a number of different milestones, such as, for example, quantum simulation and quantum chemistry, where quantum computers proved an exponential speedup. And the roadmaps for IBM provides increasing trends for both the number of qubits and reliability of quantum computers for the next years. In the context of Politecnico di Milano, we provide the Leonardo Project, in which we want to support students not only to learn new things, but also to do research and also to support their well-being and wellness through physical activities, psychology, and nutrition and sleep. And in this context, we want to collaborate with MathWorks to provide a Passion in Action course, which is an extracurricular course. This collaboration comes in the context of the curriculum development project provided by MathWorks, and we wanted to achieve two shared objectives. The first one is to provide the foundations of quantum computation and information theory to all of our students. And the second one is to help students conduct research on quantum algorithm by using the MATLAB Support Package for quantum computing to exploit its potential. Regarding our teaching, we devised two different modules. The first one is a theoretical module in which we provide students with foundations of qubits, reversible operations, measurements, and composite quantum systems, but also superdense coding and teleportation, Shor's algorithm, Grover's algorithm, and QFT, and also provide foundations of quantum error correction and quantum key distributions. The professors who taught this course are Professors Magarini and Professor Barletta. In the practice module, instead, we provide the foundations of the MATLAB environment and also practical examples of how to implement the Grover's algorithm and combinatorial optimization via QAOA and QAOA, variational quantum eigensolvers, and also quantum machine learning and quantum Monte Carlo simulation, and also provide practical examples of quantum error correction and quantum error mitigation. And here, I'm the teacher of this module. We asked our students to implement projects to show what they have learned in this course. And we selected some of the projects for publication, specifically the traveling salesman problem applied to the Milano metropolitan network, analysis of the QAOA algorithm and also cryptographic applications, quantum error correction, and also quantum key distribution. Regarding more information of the students that joined our courses, well, they come from very different backgrounds, such as computer science, mathematical engineering, engineering physics, mechanical engineering, and also electrical engineering. So we had to provide a self-containing module which covered all the foundation theory and all the required background to understand all the concepts provided into the course. And we noticed that most of our students actually came from computer science and engineering physics. All of the projects that we discussed are actually open source, and their live scripts are available on both GitHub and MATLAB File Exchange. So here you can find some QR codes to access this repository. So please give it a look and also send us some feedbacks on what you think about them. We also want to thank MathWorks for their support in funding our research activities in quantum computing, for example, for participating to international conferences and to publish papers and present posters. With this, I thank you all for your attention, and I invite you to reach out if you have any quick questions or feedback. Thank you.